Today's video is looking at alkenes and cracking, which sounds a bit interesting. We're going to start with this image on the screen of a car. And for cars to move, for us to be able to get this car to be able to move along the page or along the road, what you need is a fuel. So you need fuel for your cars to move. That's one use of fuel, but there is many uses of fuel. And in the world that we are in at the minute, there is a lot of fuel being used. And we're continually needing to find different ways of finding fuel. Now, crude oil, like I've said before, crude oil is a mixture of molecules, okay? Mainly hydrocarbons, just to remind you of that. So that's hydrogens and carbons bonded together, okay? So crude oil is a mixture of molecules, but mainly hydrocarbons. And the shorter chains hydrocarbons, so the really short ones, are really useful for us to use as fuels. So what we need to do is we need to be getting all of the not so useful long chains and making them useful. Now, one of the ways that we can do this is through something called cracking. So it's as simple as cracking something open. So if you had an egg and you crack it open, you've then got two pieces. It's the same idea. You have a really long chain and you crack it on something and it splits into two. Now, we don't hit it off the side of a kitchen worktop like you would with an egg, or wherever you're going to crack your egg on, like a knife or whatever. You actually use some chemicals to do so. So what I'm going to do is I'm going to move on to this. So here's a hydrocarbon. How do we know it's a hydrocarbon? Well, it's got hydrogens and it's got carbons. There is nothing else bonded, so it must be a hydrocarbon. It's a bit too long at the minute to be useful, so we want to crack it. We want to split it into two to make two useful things. Now, it's shown here what's actually going to be produced, but how do we get there? Well, you can have steam, so steam cracking is one type, and another way of doing it is adding a chemical called a catalyst. So catalyst cracking is another way of doing it. Let's just draw some. Yeah, and we've looked at catalysts in previous topics when we looked at rates of reaction. And we don't need to worry what it is. It's just something that we can add to it. It won't be used up in the reaction, so we can keep adding it to new things, and it will allow us to split it, because it won't split on its own like an egg. That won't crack on its own. Same, our hydrocarbon won't split on its own. It either needs some steam, so some heat to crack it, or something called a catalyst, which is just a type of chemical that will allow us to split our big chain into two smaller chains. So you can see here, the alkane, as it's called, is here, and that's got 1, 2, 3, 4 of the carbons, okay? And then it's got all of these hydrogens. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So I'm just going to write that there. It's C4H10. So I've just said how many carbons have we got and how many hydrogens have we got. Now, when we look at adding these two things together, they should equal the same number of carbons in this long chain and the same number of hydrogens in the long chain as there are in these two. We're not adding any carbons, we're not losing any of these carbons, okay? Yeah, we're cracking it in half, but we're going to crack it straight in the middle, and we're going to, sorry, not straight in the middle, but we're going to crack it, and we're going to have half on one side and the other half on the other side. So we're always going to have the same number of carbons and hydrogens at the beginning and at the end. So this side has got 4 hydrocarbons. So if we've got the 4, 1, 2, 3, 4, that means it must have cracked between this 4th and 5th one. So if I'm just going to put a little red line to show it cracking. So that's where it's split apart. So that allows us to be able to work out how many carbons would be in the other half. So there's going to be 3 carbons, so 1, 2, 3 carbons. And we've got 1, 2, 3, 4, 5, 6 hydrogens. Now I've not counted this one because that one moves there, like you can see there. That's that extra hydrogen there. Okay, so the reason we've got these ones here is you've got 1, 2, 3 carbons, 1, 2, 3, 4, 5, 6 hydrogens. Now it looks a little bit funny because we've got this thing here, and that's called a double bond. And because we've not got the right number of hydrogens, because it's had to go over there, it's double bonded. Okay, so that just allows it to happen. So the simple thing here that's happened is called cracking. So a little bit like cracking an egg, we've cracked and split our hydrocarbon up, and we've got something called an alkane and something called an alkene. If you've got one of the products, either the alkene or the alkane, you can work out what happens next. Because what you can do is you can work out where it's split, and therefore you can try and work out how many hydrogens and carbons are going to be on the other side. So I'm going to show you one more, and then I'm going to get you to have a go at working out the product. So here's one. We've got 5 carbons in our hydrocarbon and some hydrogens. And I've already drawn out the alkene, and it's saying, well, what's the alkane going to be? So we've got 2 carbons in this one, which suggests that it's going to split down the middle, and obviously that hydrogen goes with it like that. Okay? With that in mind, I can then, so I've only worked that out by going, there's 2 carbons, so counting 2 along, and then splitting it. And obviously we've got 1, 2, 3, 4 hydrogens. Well, 1, 2, 3, 4 hydrogens. Okay? So we've drawn the alkene, and we're going to draw the alkane now. So you've got, I'm just going to rub the question mark out. I've got 3 carbons. These are all going to stay the same. So I've got some hydrogens. Okay, that's how it was drawn, the first 3. And then obviously we said this hydrogen goes on the end, so like that. So there's your alkane. So it's split. We've got it cracked and split up with 2 carbons and its hydrogens on the right as an alkene, and 3 carbons on the left with its hydrogens as an alkane. Now you might be thinking, what is the difference between our our alkane and our alkene? Now I've done this with capitals because I like to think of it as alkenes have got these 2 lines here in the E's, and it's double bonds. So it's got those funny double bonds where there's 2 lines in between the carbons. Whereas alkane is single bonds. That's all you need to know. Alkenes have double bonds, alkanes have single bonds. Okay, so I want you to have a go at this one. So a bit of a longer chain. I've drawn the alkene with the double bond, and I'd like you to have a go at the alkane. Count along and work out where it's split, and remember that extra hydrogen that I'll move over to the alkane. Okay, so you should have had a chance to have a go at it. You should have paused it. I would get my red pen and I would go 1, 2, 3, 4. So 1, 2, 3, 4. I would do my little line going like that, because remember that hydrogen always pops over there. And I've got 1, 2, 3, 4, 5. So I would need to draw 5 carbons. and then the hydrogens are the same to start with. So they're all the same. Draw it out as it was originally with the 5 carbons. And then you just have to remember that extra hydrogen pops over here, and that's your splitting. You've got your single bonds, which is what an alkane is, like this, with 5 carbons. And this one's got 4 carbons and it's double bonds, so it's an alkene. So that's all you need to know. You need to know that cracking splits our big hydrocarbons so they're small and they're more useful for things like fuels, but also these alkenes can be used for plastics. Okay, so we're splitting to make them more useful, whether they be fuels or alkenes, and they produce an alkane and an alkene. That's what you need to know. And being able to predict this is a bonus, yeah? Being able to predict the things that are produced after you've got one is a bonus here. So if you've done that, that's really, really good, okay? And final thing I want to go through is that alkenes are more reactive than alkanes. So they're really, really reactive. And if we've got, because they're colourless, if we've got 2 colourless liquids and we don't know which one's the alkane and which one's the alkene, what we can do is we can add it to something called bromine water. So if I was to add a nice simple alkene like this, C2H4, if I was to pop it in there, let's use this. So if I was to pick it up, if I was to be able to pick it up and move it and place it in there, so that would be a liquid, pour the liquid into your bromine water, what would happen to the bromine water is it would go colourless. So it goes from brown, so bromine water goes from brown to colourless, and that's a really important thing. And it only works with alkenes. So if I was to have done it with an alkane, the bromine water would have stayed brown. And the reason is because alkenes are more reactive. So they're more reactive, so they will react with the bromine water to make it go colourless, but the alkanes aren't reactive enough, so they won't be able to make the colour go colourless. It'll stay brown.